Hey guys, welcome to section 7 for Physics in the Flesh, one-dimensional momentum. In this problem, we're going to be looking at conservation of momentum. A child in a boat throws a 6.04 kilogram package out horizontally with a speed of 11.0 meters per second. Calculate the velocity of the boat immediately after, assuming it was initially at rest. The mass of the child is 25.0 kilograms and that of the boat is 44.0 kilograms. Ignore water resistance. Okay, so in this problem, we've been given a schematic of what's going on. You've got the boat, the child inside, the package being tossed out. Now, one of the key parts of this question is that initially they're both still. The package is in the boat with the child. None of them are moving. Okay, so in the beginning, when we set up our conservation of momentum statement, that the momentum at an initial point 1 is equal to the momentum at a later point 2. Total momentum initially equals total momentum later on. Now, we have to also assign subscripts for the different objects we're dealing with here. So the two main things we have here are the boat, which includes the child, and the package. Okay, so we're going to use B for boat and P for package. So when we set up our statements for conservation of momentum, we're going to have, well, P is equal to mv, right? Mass times velocity. So P is equal to mass of the boat times the initial speed of the boat, v1b, plus mass of the package times the initial speed of the package, which equals mass of the boat times final speed of the boat plus mass of the package, final speed of the package. So mp(v2p). So there you go. Now is where you can start simplifying this expression. Initially, it says they're initially at rest. Now the package is obviously with the child in the boat, so therefore v1p and v1b are both 0. Package isn't moving, boat's not moving. So both of these two expressions disappear. And you know, once you start getting more familiar with these problems, you can just simply jump to P1 equals 0. You don't even need to write this, but I would strongly encourage you to do so until you get used to that idea. Why is it 0? Okay, so the initial momentum is 0, therefore the final momentum has to cancel out, which means if the person or the child throws the package out, for example, forward, the boat has to move backward to compensate. Now, obviously, the boat's not going to move backward by that much because the package is light. It's going to go off with a higher speed. Because the boat is heavier, it has the child inside as well. It's going to move back, but a little bit slower. It's almost like the recoil speed of a bullet in a gun. When the gun shoots the bullet goes fast, very far ahead, but it's a very lightweight. You, as the person who shot the gun, you're going to have a recoil momentum as well, but because you have a higher mass, your recoil speed is significantly less. Okay, so now we have 0 equals mb v2b plus mp v2p. And the question is asking us to find the velocity of the boat immediately after. And like I mentioned, that includes that of the child. So we're looking for v2b. So at this point, we need to isolate for that. So bring the mp v2b to the left. It's going to become negative. So minus mp v2p. And we have to divide both sides by mb. And that's going to be equal to v2b. So at this point, you just have to solve for your unknowns, plug in your values. I'm going to rewrite v2b on the left. So v2b is equal to negative. Mass of the package, they tell us, is 6.04 kilograms. So 6.04 kilograms. It's thrown out horizontally 11 meters per second. 11.0 meters per second divided by mass of the boat. Now remember, that's pretty much everything that's left over. That includes the child. So 44 plus 25, so 44.0 kilograms plus 25.0 kilograms. And when you calculate this whole expression through, you're going to get v2b is equal to negative 0.963 meters per second. And that is correct to the right number of sig figs because we have 3 in the question. And just as a check always in your physics problems, make sure the answer makes sense. Okay, so as we logically determined earlier, because the mass of the boat with the child is considerably larger than that of the package, it needs to have a smaller recoil speed, which it does. 0.963 compared to 11. Okay, so the answer makes sense and it's negative. Okay, so that makes sense as well. If the package is going in one direction, therefore the boat is going in the opposite or its negative direction. So this must be a minus sign. Guys, so that's it for this video. I hope it made sense. If you have any questions, be sure to leave them in the comment section below. Otherwise, smash that like button if you enjoyed it and subscribe to Physics in the Flesh if you want to keep seeing these videos to help you with your homework or even if you want to just brush up on your physics. All right, guys, I will see you tomorrow at 12 noon for video 119. Conservation of Momentum 2. Hey guys, that's it for this episode. If you enjoyed it, be sure to check out some of my most recent videos posted over there on the right, which you can click on your screen right now and watch. Other than that, guys, I hope you enjoy the rest of your day, and I will catch you in the next video. Is the end screen too long this time? Wait, you're still recording? No! Oh. Gotta move that chair out of the way now.